Today, we will reveal that the universe didn't begin with the Big Bang. The universe is an endless, ambiguous, and ever-changing place. It displays aspects of itself that men have never before seen as it develops. The Big Bang Theory, formerly regarded as the most plausible explanation for how the universe came to be, has recently been shown to need to be more accurate. Practically every religious and cultural group has a unique explanation for a phenomenon that is so widespread. Many theories explain the universe's origin, each embodying a certain group's ideology. The Big Bang Theory is the more widely accepted account of the universe's origin in general science. Because scientific laws have completely supported it, this idea is more useful. The Big Bang occurred at a specific point in time, and for a long time, scientists have agreed that nothing existed before this period. The general idea is that the Big Bang occurred approximately 13.7 billion years ago, and before that, there was absolutely nothing, neither matter, time, nor space. Matter began to exist only during and after the Big Bang, and this theory attempts to explain what happened during this moment. This theory states that only one atom was present at the beginning of the universe. Think of this atom as a tiny ball that contains everything that is currently present in the cosmos. Despite having an unfathomably small volume, this ball-shaped atom possessed a very high overall density and temperature. Theoretically, this unique atom was situated at the regions of extreme gravitational pull, now known as black holes. Nobody knows how or why the atom emerged. Still, scientists know that it violently exploded from a tiny ball and that everything in the universe today resulted from that explosion. Along with the concept of matter, time and space were also created due to the Big Bang. The explosion caused this then singular atom to split into tinier particles with less density. These particles began to interact with each other, causing the expansion of the universe. When you think of expansion, you think of an object stretching its defined boundaries within a wider environment. But with the universe, it didn't quite work like that. The universe has no borders. The universe is all there is. So rather than saying it was expanding into space, the universe was expanding on itself. Quite interestingly, it has been expanding ever since. Within the first second, energy from the explosion was converted into two opposing types of particles: matter and antimatter. Matter and antimatter interacted within and among themselves, producing energy in more particles. As time passed, the quantity of both forms of particles became theoretically equivalent. As this expansion continued, matter and antimatter continued to oppose each other. However, much matter there is, today there is barely any antimatter left. The universe expanded over 1 billion times its original dimensions, and temperature and density were spread unevenly throughout. Less energy was expelled as energy was utilized to hold particles together to form larger ones. Quarks came together in different combinations to form hadrons, like electrons, protons, and neutrons. As the universe became less hot, protons began to combine with neutrons, and the first atom was created: hydrogen. Many hydrogen atoms were made, and after accumulating for millions of years, the hydrogen atoms, which had been under intense gravitational pressure, exploded. As stars were formed, visible light began to permeate the universe. From tiny particles, larger particles began to form, and the universe birthed itself into a long, gradual, and continuous process that produced everything we see today. However, contrary to what we believe over the years, the universe did not begin with a Big Bang. In the 20th century, great scientists came up with theories that explained the nature of the universe, and many of these theories supported the Big Bang Theory. One of the most significant was Einstein's theory of relativity. In 1915, when Einstein proposed his theory, it wasn't easy, and not all the equation variables were clearly defined. However, the genius scientists predicted some of these variables, which were discovered a few years later. For example, in 1916, Carl Schwarzschild found a solution that describes a non-rotating black hole. As aforementioned, the black hole is a point in the fabric of space where the gravitational force is at its greatest. As objects approach the black hole, the rotational speed increases. But if this object falls into it, all motion ceases and there is no way out. In 1922, Alexander Friedman discovered the solution of an isotropic and homogeneous universe. All types of energy, including matter and radiation, were present here. An immense significance of Friedman's discovery is that it describes how the universe is never passive. It must either contract or expand. Friedman's equation describes very accurately the series of events that occur in each stage of the development of the Earth, from pre-Big Bang era to the Big Bang itself today and far into the future. The dynamism of the universe was further elaborated by astronomer Edwin Hubble, for whom the Hubble telescope is named. In the early 1900s, astronomers observed that nebulae, essentially clouds of hydrogen and cosmic dust, were moving faster than any object in space. The closer they observed, the more they noticed smaller nebulae moving away from us with greater speed than the previously observed ones. Edwin Hubble conducted further research in the 1920s and measured the distance between the stars in each nebula. He noticed they were moving away from each other, and the distant stars move apart faster than the closer ones. Hubble and a few other scientists confirmed that the universe was expanding through this experiment. According to them, the further you look into space, the further you look into time. Therefore, the theoretical prediction of the state of earlier universe elements could be practically confirmed. This experiment confirmed that shortly after the Big Bang, the universe consisted of tiny particles, mostly unstable due to the infinite temperature. However, the Big Bang theory has provided factual explanations of the universe's beginning. The theory has a few limitations, some of which are explained by cosmic inflation. We've established that the Big Bang theory was the driving force behind the universe's expansion. Still, there are some observable properties in the universe that the Big Bang theory cannot explain. An example of this is the uniformity of the universe. The idea of the Big Bang is that a tiny particle exploded into smaller particles. Still, the uniformity of the universe that is now observable can only mean that these particles in the beginning must have been smaller. A phenomenon called cosmic inflation explains this similarity. Cosmic inflation gives an explanation that precedes the Big Bang and is fundamentally based on the fact that gravitational force can sometimes act as a repulsive force. This contradicts our high school idea of physics because we know that gravity is an attractive force between two bodies according to Newton's universal law of gravitation. However, Einstein's theory of relativity explains that, ideally, gravity and attractive forces can sometimes act repulsively under certain conditions. Modern particle physics supports Einstein's theory that certain sorts of particles would generate their repulsive form of gravity at very high energies. Fundamentally, the Big Bang wasn't random. It was caused by repulsive gravity within the initial lone atom's atomic components. How does cosmic inflation explain the properties that can be observed in the universe now that we have a better understanding of it? If the cosmic inflation theory is true, it is possible to think of the universe as having started as a tiny universe that the Big Bang then blew up and projected onto a bigger size. Before inflation, the universe's constituent parts were sufficiently identical to one another to achieve the current uniformity. This implies that the Great Bang was caused by inflation, which had already caused the cosmos to be uniform. The strongest proof of this consistency is provided by cosmic background radiation. It shows that the cosmos is almost uniform at the biggest sizes feasible, with an accuracy greater than 1 in 10,000. People are still determining the exact length of the inflationary period. In reality, time didn't exist at all during that time. We knew that cosmic inflation sets off the universe's evolution, and as a result, the universe's expansion rate and matter energy are currently in balance. In conclusion, cosmic inflation only reveals that the Big Bang idea wasn't the beginning as we always believed. It does not in any way undermine it. That is our video for today. We hope you like it. How do you think the universe began? Share all of your thoughts with us in the comment section below. Well, that's all for now. This is Big Tech Media. See you again tomorrow. Keep in mind to like, share, and subscribe.